Hi students, problem number 5. Calculate the mass defect and binding energy per nucleon of the silver nucleus. So what are all the given quantities here? The mass of a silver atom is given. So 107.905949 U. U means atomic mass unit, unified atomic mass unit. And mass of the hydrogen atom, which is the sum of one proton and electron. So that is 1.00785 U. And the mass of one neutron is 1.008665 U. Now we have studied in the regular class mass defect of a nucleus separately and mass defect of the atom. So when you want to find the mass defect of only the nucleus, their electron's mass will not be considered, is it not? But here this is the atom, mass of the entire atom is given. So the mass defect of the entire atom we are going to find out, including the mass of the electrons. So now before that, here what is this number 47 indicate is Z, that is the atomic number or number of protons. So number of protons is equal to 47. Okay, and what is this number 108 means? It is a mass number, A, is it not? A, that is A is equal to 108. This includes what? Protons plus neutrons is equal to 108. Therefore, number of neutrons is equal to 108 minus 47. Okay, and that is equal to 61. So, how many number of neutrons are present is 61. How many number of protons are present is 47. Okay. Now, mass of the hydrogen atom. Okay, mass of the hydrogen atom is 1.00785. Now, the mass defect of the entire atom I am going to find out. Okay, mass defect of a silver atom is given by the formula delta M. This is equal to Z, the atomic number, into mass of the hydrogen atom. I am going to express in terms of MH plus N number of neutrons into mass of one neutron minus of this mass of the atom. This is the mass measured by Bainbridge mass spectrometer, the actual mass measured, which will be always less than the constituent mass. So this is the mass defect of the entire atom. I am going to substitute the given values, that's all. Okay. So now this is equal to Z. Z is how much? 47. So this is 47 multiplied by mass of hydrogen atom is 1.00785 U. Okay. Plus number of neutrons is 61. So 61 multiplied by mass of one neutron is what? 1.00865 U minus of what is the mass of this atom given here, we have to substitute. So 107.905949 U. So now we are going to use the calculator. So 47 multiplied by 1.00785 into 47. Now all the digits let us write. So this is equal to 47.36895. 36895 plus 61 multiplied by this number. Okay, so 1.0086658 multiplied by 61. So this is now equal to 61.5252865. Okay, this is to be added minus of this 107.905949. Now I will add the first two numbers and then subtract the third number from the sum. So 47.36895 36895 plus 61.528 565. So this sum is equal to, this is sum equal to 108.897 515. So this is the sum of the first two numbers minus of the third number 107.905949. So we have to subtract this. Minus of 107.905949. This difference is coming as 0.991566U. So U means what? Unified atomic mass unit. Okay, now this is the mass defect in atomic mass unit. In million electron volt, if I convert, that will give you what? The binding energy. So the corresponding binding energy must be equal to this mass defect multiplied by 931. And if mass defect is expressed in unified atomic mass unit, then here the unit will be what? A million electron volt. Okay. So this is now equal to 0.991566, okay, into 931. So this is 0.991566 multiplied by 931. So this is 923. This is 923.15 million electron volt. So this is the total binding energy required. Okay, the total binding energy required for how many particles? 109. Okay, 109 particles. But binding energy per nucleon is to be determined. So this is the total binding energy. Okay, therefore binding energy per nucleon Be bar. So this is equal to what? The binding energy divided by the mass number. So this is now equal to 923.15 divided by the mass number is what? 108. So this is to be divided by 108. So now let us check 923. Okay, 923.15 divided by 108. So this must be equal to 8.54. So this is a 8.54 million electron volt. So this binding energy per nucleon also is called as specific binding energy. So first we have to find the mass defect of the entire atom in terms of the mass of hydrogen atom, and we got the value 0.991566. Then we multiplied by 931 and converted into binding energy in units of million electron volt. So Be is the binding energy for the total nucleus. So only for one nucleon, that is called as binding energy per nucleon, that is specific binding energy is binding energy divided by the mass number. So we got the answer 8.54 million electron volt. So this type of problem is very important for the government board examination. Okay, I hope you must have understood well. Fine.